we're now going on to the log graph, and then as promised, I'm going to give you one big compound graph where we're going to be doing graph interpretation. Now, this being a very important concept, we're taking it over a variety of episodes. So obviously all that work, remember this is 2 years work being crammed in 1 hour. So guys, you guys need to bear with me. Okay, now we ended up yesterday with the exponential graph, and we said that the exponential graph was y equals a to the x. The log graph is the inverse function of the exponential graph. So where exponential is y equals a to the x, your log graph is the inverse function x equals a to the y. Now this is specifically targeted at grade 12 learners only. Grade 11s, you don't need to know this at all. Okay, but if you want to start, if you are watching and you are interested in mastering the grade 12 content, be my guest. Okay, now let's explain to you what is a log. So before we actually go into log graphs, let's explain to you what is logs and why do we use logs. Now you do know that when we had 2 to the power x was equal to 8 from our exponential equations, in our answer where we had to solve for x, what did we say? We said we had to make the bases the same. So then we said 2 to the power x was equal to 2 to the power 3, right? Because the 8 is 2 to the power 3. We made the bases the same, x was equal to 3. What happens, so you as a grade 11 might have asked, or grade 12 learner, what happens if we cannot make the bases the same? So here's the situation, 2 to the power x is equal to 9. Now we cannot make the bases the same, hence the need for logs. Okay, we use logs when we cannot make the bases the same. Now grade 12s, you're not only going to be using this in functions, you're going to be using this in functions, you're going to be using it in sequences and series, you're going to be using it in finance. Wherever x is in the power, wherever there's an unknown in the power and you need to make the power the subject of the formula, that's when you will use logs. So logs is used when you need to make the power the subject of the formula. So logs is used when we need to make the power the subject of the formula. Hence the need for logs. Why? Let me show you. So if this is the question, 2 to the power x is equal to 9, in your answer we will attach a log. So you attach a log on the one side, you attach a log on the other side. So basically what we're going to do, we're going to say now log, there's it, we've attached a log, 2 to the power x is equal to log 9. Now logs is the only rule in mathematics that allows you to bring the power in front. So the power now becomes the base. This power shifts in front of the log. So what do you have now? In your next step you have x log 2 is equal to log 9. Now it's a normal equation, divide by log 2 because you're solving for x. Remember the question said solve for x. So divide by log 2, divide by log 2, x is equal to log 9 over log 2. Now x is equal to, you can go to your calculators, your scientific calculators, punch in there log 9 divided by log 2, you get 3,16999. So you get 3,16999 blah 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 blah. So x is approximately 3,17. And there we go. That is how we solve for x when x is in the power. Hence the need for logs. Now this, the exponential graph, the exponents or exponential equation had an equation. So hence the log graph must also have an equation. Now they are inverse functions. The one is the opposite of the other. So just to show you the log, okay, hope you all took all these notes down. Okay, in the exponential graph, here's the exponential graph, here's the log graph. When we had y equals 2 to the power x in exponents, what did we have? We had a graph that went like this and we had a graph here. Remember we had only one y-intercept, 0 and 1. I hope you remember that from our previous episode. That all standard exponential graphs have only one y-intercept, and that intercept was 0 and 1. Now these are the inverse functions. So the log graph for this function will be x is equal to 2 to the y, and sometimes in the exam they will say give the inverse function, grade 12, they'll say give the inverse function of the exponential graph. So if the exponential was y equal 2 to the x, the log graph will be x equal 2 to the y. But they will also tell you write it in the form y equals. They want y to be the subject of the formula. So you just say y is equal to log, what's your base? 2, log base 2x. There we go. That is your inverse function. So these two functions mean exactly the same thing. X equal 2 to the y, y equal log 2x, exactly the same function. Now, how do we sketch the graph? Now, if they are opposite, if they are inverse functions, grade 12s, if the exponential graph has only one y-intercept, the log graph will have only one x-intercept. Where this point is 0 and 1, the coordinate here would be 1 and 0. So the log graph now would go in that direction, going through the point 1 and 0. So they are your inverse functions. So a positive log graph will look like that.